Hello students. So today I am going to give you brief instruction on one extra experiment you are going to do in microprocessors and interfacing lab. You may not be able to do, I think, all the hardware experiments which you're supposed to do because of this 4 weeks break for the safety reasons. But same time, we don't want you to uh, missing this microprocessor lab. So we are giving you one extra experiment which can be executed using turbo assembler. Turbo assemblers are available, and I think I have also communicated with you all. You can just install it in your system and you can conduct this experiment. Now this experiment is on graphics operation, and we're going to use public and external directives and trying to write some programs which gives illustration for this public and external directives. We will see what is this public and external directives. Before that, let us see a program to draw a rectangle on a display console in graphics format. So you have already used interrupts, DOS interrupts, what you call it as BIOS and DOS interrupts. You have done some programs to open a file, put a text, a string inside a file, and also to display system date, to display system time. All these things you have already done by using simple DOS interrupts. So today I am going to tell you how do you draw a rectangle of different colors, or how do you draw any shape on the display console using assembly program. Right? Okay. So before that, I would like to give you a link which gives you information about all these DOS interrupts. So let us see. You can see on the screen, right? You can see on the screen all these are interrupts, right? You have interrupt 10H, interrupt 11H, interrupt 12, interrupt 13, 15, 16, 19, interrupt 20, interrupt 21. Most of the time interrupt 21 you have used, right? So all this interrupt information is available in this particular link. Now let us click on this interrupt 1000H. What is this interrupt 1000H? See, your interrupt 1000H means you are going to put 00 into AH register and you are going to call interrupt 10, and it does a specific operation. What is that operation? You can see here. See, so you have to move 00 into AH register, and then in AL register you have to put desired video mode. What is that video mode? You can use the display console in text mode and also in the graphics mode, right? So now you can see if you put 00 into AL register, okay, if you put 00 into AL register and if you put 00 into AH register and then call interrupt 10H, then the display is set to text mode with 40 rows and 25 columns. 40 rows and 25 columns, right? It is 40 by 25. Sorry, it is 40 width and 25 length. Similarly, if you put 03H, it is 80 into 25. It is 80 into 25, right? With the 16 colors, 8 pages. With 16 color, 8 pages. Suppose if you put 13H into AL register and AH00 and call interrupt 10H, then you are getting into graphics mode. With 320 into 200 pixels. 320 into 200 pixels with how many colors? With the 250 colors mode. Then you have other interrupts, okay, to put pixel on the image so that using that pixel you can draw anything on the display console, right? Okay, so now let us go back to the program, right? Now see how to draw a rectangle. So normally, how do you draw a rectangle? Suppose if you want to draw a rectangle, how will you draw the rectangle? You will draw a horizontal line, right? So you will draw horizontal line and you will draw a vertical line, and then you complete a rectangle, yes or no, right? Okay, so now I will just explain you how do you draw a see, suppose if you want to draw a rectangle, how you draw it? First you will draw one horizontal line, right, and another horizontal line, and then another line here, okay, and another line here. So you draw this to get a rectangle. Now how it is drawn? See, suppose if you see this, suppose if you zoom this, okay, and see this particular image, it is actually, okay, made up of pixels. These lines are made up of pixels. If you still zoom to the very high value, you can see these lines are made up of pixels, right? All these pixels are put together to form a line, right? Like this. See, I will draw, see, one another pixel, another pixel, another pixel, another pixel. See, like this. Like this, you have to put a pixel to draw the line, right? So one line like this, another line like this, another line like this, okay, another line like this. Exactly, you get one rectangle, right? So just by putting pixel by pixel, we will try to draw a rectangle using assembly programming, right? Okay, so let us go to the program. As usual, you have dot model small, dot stack 100H, okay. Whether you use stack or not, let it be there, it is not going to harm you, okay. And we are declaring this width and height. By changing the value of this W and H, it is possible to change the width and height of the rectangle which you are going to draw, right? Okay, so these are not going to be stored in the memory. These are constants because EQU is used. It's already explained to you that what is the meaning of EQU, right? Okay, so these two are the only data we used here. Then dot code as usual, dot start, okay. See, we are not using move ax comma add data, move ds comma ax. Why we are not using it? Because we are not storing any data in the memory, right? Okay, now see, move h comma 00, move al comma 13h, interrupt 21h. What is happening when you execute these three? Your display is set in the graphics mode. That is what I have shown you here, right? Display is set in the graphics mode. 13H means it is in the graphics mode, okay. So first display is set in the graphics mode. right? Display set in the graphics. See here, right? Next, see, next we will draw upper line, right? So which one we will use? We will use, we will use same interrupt 10H with 0CH in the H register, with 0CH in the H register. Okay, now let us see how to use this. Let us go to the DOS interrupt. So now we have to use 0CH. See, 0CH. See here. Interrupt 10H, AH is equal to 0CH. Now, what are the requirements? See here. AL is pixel color, right? AL gives you the pixel color. Okay, see, for AL is how many? 8 bit, right? This 8 bit combinations, okay, will give you the pixel color. Okay, now you have a table for the pixel colors, right? Okay, see here, you have the table here. So this is called bit color table. Okay, you can see bit color table here, right? Okay, so now you can use the same bit color table here, 0CH, right? So you have a choice of any color to be used, right? See, and CX gives you column number, DX gives you row number. Okay, CX gives you column number, gives you row number. You can set the rows and columns, and you can just put a pixel of any color, and that color information is available in the AL register, right? Okay, so hope you understood this. Okay, now what are the requirements for just displaying a pixel on the screen in graphics mode? Interrupt 10H with AH register with 0C, AL register is the pixel color, and CX is the column number, DX is the row number, right? Okay, so now let us go to the program. See, now we will draw a line. How do we draw a line? So if you just display the pixel, if you display some 100 pixel, you will get a line. Okay, right? Dot 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 100 dots will constitute a line. Hope you are understanding this. Okay, that's what we are going to do here. See, now CX, I told you CX column number, DX is the row number, right? Now to draw a horizontal line, okay, draw a horizontal line, okay, we are just changing the column number, right? Row number remains same. Keep the row number same and change the column number and just try to draw the pixels. Okay, see here. Initially set, okay, initially set the CX to 100 plus W. W is already declared, right? Initially set the CX value column number to 100 plus W. Row value to 20. It will go to the 20th row. Okay. Now AL15. AL15 means it is 15 in decimal. In hexadecimal it is 1111. Hope you understood this. Okay, which you get from that color table. Now move AH comma 0CH. This is for put pixel. Interrupt 10H. What happens? This will display a pixel at column specified in CX register, row specified in DX register, and with a color specified as a white. Okay, have you understood this? Okay, now If you just draw one pixel, it is not going to be line. If you want a horizontal line, you have to put some 100 pixels or 50 pixels depending on the width required, right? So what is done here is, see here, decrement cx value will be decremented by 1. Compare cx with 100, right? Compare cx with 100, right? You started from 110 and you just compare with 100 so that 10 pixels can be drawn. Okay, see here. Now suppose w here is taken as 30, right? Now initially your cx is 130. So at a column number 130 and row number 20, it will put a pixel. After that, decrement cx, compare cx 100, right? Now it will, if it is not 0, okay, jump above or equal u1, right? Okay, jump above or equal. Okay, see, jump above or equal means it will come out when it is equal. Okay, it will jump above or equal. That means till 100 it will just take the value and it will come back to this u1 and it will continuously put the pixel on the screen. Hope you understood this. Okay, I will explain you once again. See, this particular code is going to draw a line on the graphics mode of the display console just by putting pixels, right? Okay, so I can just uh, explain you this. I'll just go back to, okay, now you see here, see, it will first put one pixel here, okay, and then put another pixel here, another pixel here, pixel here, pixel here, pixel here, like this. It will just put the pixel. So it will start from 130 position here. So it will put pixels from 130 to 100 because cx is decremented. So it will draw a line like this. So this entire set of code is drawing a line like this in graphics mode. Similarly, now keep cx constant, okay, increase or decrease dx, you can draw this. Similarly, you can draw this and you can draw this. So you will get a rectangle, right? That is what done on this program, right? So here you can see this is drawing upper line. So bottom line you draw, bottom line you just change dx, use similar code here. Similarly, left line, in left line keep column number same and change the row number, right? One below the another, it will, well, one below another, it will put the pixel and draw the vertical line. Okay, just use this row and column values and try to draw the pixels. Okay, so you will be able to see a rectangle drawn on the graphics mode, right? Okay, so try to execute this program. Okay, so I can just show you executing this program. just save it as so don't try to do the method whatever I have run. Try to type in the program, because in the examination you have to type the program. Okay, and this DOS manuals are available to you. Okay, so I'll just give it as myrect.asm. Okay, so I'll just now go to turbo assembler. So let us see. So I'll just do edit myrect.asm. These are the programs. You can see these are the programs. Hope you understood the program. Now I'll just execute, use tasm myrect.asm. There's no error. So t-link myrect.obj, and similarly now you can just execute this program myrect. You can see a rectangle drawn on this, right, with the width 30 and height 5. Okay, now you can change this. Just go to edit myrect.asm. Now I'll just change the height to say around 20, and this I will change to around say 110. Okay, now save this once again. Now exit, do tasm as usual. Similarly do link. Now execute this directly. Okay, now see it is drawing a bigger triangle on the console. Hope you understood this. Okay, execute this program, try to understand, use the DOS table which is sent to you as a link, right? Okay, so we will I will send you one more video with respect to the other programs. Okay,